Okay, we're going to finish off this unit by doing another experiment. You've watched a video and submitted it. So let's do the experiment on how does the body stay cool. So the first thing we need to do is gather our tools that we need, or the materials. You need 3 paper towels, 3 thermometers, 3 paper plates, marker, a graduate cylinder, water, rubbing alcohol, and a fan. If none of these things are available, if these things aren't available over there on the science table, please talk to me. Now we have to set our purpose for doing this experiment, so get out your book, page 167, and our purpose. What will we learn from this experiment? I will learn which cools faster, a dry towel, a towel with water, or a towel with alcohol. Then write your hypothesis or testable statement. I hypothesize the towel, which one will keep it dry fastest. Will cool the fastest. We want not dries, but cools the fastest. So what would cool your body down the fastest? Which sample is the control? Which one has the base? Well, obviously, after you've written it down, see if you've got the right answer. It's the dry towel. The dry towel has no bearings how fast or cool it is. Check that temperature first. Now you need to record your observations in a data table. So what you want to do is you want to draw yourself a table. Now I don't care if you draw a table that goes like this. And at the top you write dry towel. Dry towel, wet towel, an alcohol towel, and over here, what was the temperature after so many minutes? So we could say after, let's see, does it tell us exactly how many minutes we're supposed to write? After every minute and for 5 minutes. So we're just going to need, okay, the temperature, and I'll need 5 of those. So here would be your first minute, here would be your second minute, your third minute, your fourth minute, your fifth minute. You can do it that way, or you could do one separate one and just do this, and then 1 minute, 2 minutes, 3 minutes, same thing, but only put dry up there. You decide what kind of data table you need to do really good record keeping, because remember, the most important part of the experiment is writing down the data. Alright, let's start the experiment. What do you got to do? Wrap a paper towel around the bottom of each thermometer. Place each thermometer in a place. On the plate. Label the plate: dry, water, and alcohol. Record the starting temperature of each thermometer. So when you're making your data table, you got to put the top, you're going to have to put normal temperature or starting temperature. Make sure the water is at room temperature. Measure 50 milliliters of water. That's what your graduate cylinder is for, to measure that out. Pour the water on the paper towel on the plate labeled water. Then do the rubbing alcohol one. Place all 3 plates in front of the fan. Record the temperature. So you can either use the clock, or you can come get the stop clock from me for every minute if you'd like. Either way works for me. So then record your data. How did these two match up? Did you guess the right one? Did you hypothesize the right one? Not guess. Then finish the page on this side. Write down all those informations, and then let's do the quiz. Write your answers. Carlos wraps 4 thermometers in paper towels. He adds liquid to 3 of the paper towels as shown. He used alcohol, oil, and water, so he did a little differently. He let the paper towels dry for 10 minutes in front of a fan. What will a difference in the temperature of each thermometer tell Carlos about the evaporation? So this is just like the experiment we just did. Will it tell evaporation does not occur at room temperature? Liquids that evaporate quickly lower temperature quickly. Covering keeps thermometers warm and stops evaporation. Thermometers wrapped in different ways measure different temperatures differently. So which one of those really was our purpose of doing the experiment? Sorry, this page is how I did my graph. Second question. When Tina wets her fingertips with the nail polish remover, her skin feels cool as it dries. How is this process similar to the way the body uses sweat to cool itself? When the remover evaporates, it adds salt to the body. When the remover evaporates, it adds heat to the body. When the remover evaporates, it removes salt from the body. When the remover evaporates, it removes heat from the body. And remember, the question wants to know is, how does this body use the same way sweat? So what do we know sweat does to our body to cool it? When a person gets hot, his or her skin produces sweat. When a dog gets hot, it uses its moist tongue to pant. Why does a person's body cool more quickly than a dog's body? A person has a higher body temperature than a dog. A person's body is usually much heavier than a dog's body. A person can also stick out his or her tongue. A person's skin has much more surface area than the dog's tongue does. How does sweat cool the body? It adds heat to the body when it evaporates. It adds heat to the body when it turns to a liquid. It removes heat from the body when it evaporates. It removes heat from the body when it turns to a liquid. Abdul swabs one of his sister's arms with water. He swabs the other arm with rubbing alcohol. Then he asks her to describe which feels cooler. Why is Abdul's experiment not a scientific way of testing evaporating and cooling? No evaporation takes place. He doesn't apply the test on his own arm. His sister's opinion is not a verified observation. The amount of water and alcohol are not the same. So let's look back. Why is it not a scientific way of testing an environment, evaporation and cooling? And then we are ready to completed this lesson.